logarithms. In this lesson, we'll be taking a look at the definition of logarithm. We'll be considering how to change logarithm to indices. Then we solve some few problems on logarithm. Let us start with the definition of logarithm. The logarithm of a number is the power or index to which a base must be raised to produce the given number. Again, the logarithm of a number is the power or index to which a base must be raised to produce the given number. Consider this relation: log n to base x is equal to y. Log n to base x is equal to y. Our x is the base. We say x, the base, raised to the power of the y will give n. Therefore, x raised to power y is equal to n. Consider the logarithm indices relationship. Log 125 to base 5 is equal to 3. 5 is the base, and we have the number 3 here. We can say that this 5 raised to power 3 equals 125. Therefore, we have 5 raised to power 3 equals 125. Also, we can have log 2 to base 16 to be equal to 1/4. Remember, we start with our base, which is 16 here. 16 will raise this power 1/4, this number 1/4, so that we have 16 raised to the power of 1/4 is equal to 2. So we have 16 raised to the power of 1/4 to give us the answer 2. We say let log 16 to base 2 equals x. Remember from the definition of logarithm, the base 2 can raise this x as a power to give us 16. So we have 2 raised to power x is equal to 16. Now our 16 will be in terms of 2. That is, how many times can we multiply 2 to give us 16? We can have 2 times 2 times 2 times 2 giving us 16. That results into 2 raised to power 4 because we have 2 in 4 places. So we have this as 2 raised to power x is equal to 16, which is 2 raised to power 4. So at this point, we have this base to be equal. We equate the base. Equating the base, we say that x is equal to 4. Therefore, log 16 to base 2 is equal to 4. This example is similar to the first one. We can also have our log 1/3 to base 9 to be equal to a letter like a, so that we have 9 raised to power a equals 1/3. Now, 9 is having the prime number 3. That means we can multiply 3 by 3 to give us 9. That is 3 in 2 places. 3 raised to power 2 with the a. And this fractional number we have, the 1/3, can turn to 3 raised to power minus 1. So we have our base to be equal. We can also equate the base in this case. So now we have 2a is equal to minus 1. Dividing both sides by 2, we have over 2, 2 cancel 2, so a is equal to minus 1/2. Therefore, log 1/3 to base 9 is equal to minus 1/2. We have log 343 to base x is equal to 3. In this example, we have a ready-made equation. left hand side, right hand side, unlike the previous two examples. So we can just apply the definition of logarithm, which is x, the base, raised to the power of 3 equals the number 343. Now, we have our power to be known, not the base. So we think of how many times, we think of the number we multiply 3 times. The number we multiply 3 times to give us 343. If you try 7 times 7 times 7, you will get 343, which means 7 times 7 times 7 is 7 raised to power 3. So I have x raised to power 3 equals 7 raised to power 3. Now, my base here is x, my base here is 7. They are not equal. The power here is 3, the power here is 3. So I will equate the powers. I will equate the powers so that I will have my x to be equal to 7. We have log x squared minus 5x plus 50 to base 10 to be equal to 2. From the definition of logarithm, you can say base 10 raised to power 2 equals the number x squared minus 5x plus 50. So that we have 10 raised to power 2 means 10 times 10. That is 100. And we have x squared minus 5x plus 50. If I bring this 100 to this right hand side, we have a 0 here. We have x squared minus 5x plus 50 minus 100. So that we have 0 equals x squared minus 5x. 50 minus 100 is minus 50. I can rearrange this to give me x squared minus 5x minus 50 equals 0. Now we have a quadratic equation. We think of two numbers that will give us minus 50 and we add to give us minus 5. You will agree with me that those two factors are minus 10 and 5. So I will split this minus 5 using minus 10 and 5. So we have x squared minus 10x from this minus 10 and plus 5 from the other 5. Our minus 50 is still the same with the 0. Now factorizing this, x is common to the two of them. I can say x into bracket x in x squared, it remains 1x, minus x, cancel this x, it remains 10, plus x, 5x and minus 50, 5 is common. So we have 5 in 5x. 5 cancel this 5, it remains x. We have a minus sign. 5 in 50 is 10. Remember, for a quadratic equation, the brackets should have the same thing. So we can pick one of the brackets, which is x minus 10, and we pick the two terms outside the bracket. We have x and plus 5 equals 0. So we can conclude by saying x minus 10, one of the brackets, equals 0, or x plus 5 equals 0. So we have x to be equal to 10 or x to be equal to minus 5. I hope you enjoyed the lesson for today. So far so good, we're able to define logarithm. We're also able to talk about the logarithm indices relationship, and we're able to solve some examples using the logarithm indices relationship. I would like you to practice some questions that you can see on the screen.